All right, so we're going to start on pandas today. We have two documents for pandas, and it's really cool stuff. Pandas is very similar to SQL in a lot of ways, in the ways that we're really going to end up using it for the most part. We've got the same aggregations, things like that. So I highly recommend making sure you have good SQL skills before you move into this. But it should be good, and we'll go ahead and get into it. So first off, I want to have a look here at NumPy. We just got through that document, NumPy random sampling, and this is just a little way of how we in NumPy would generate random numbers. So this will just generate a random number, and if I run this cell here, you'll see that these numbers are all between 0 and 1. If you want to, though, you can extrapolate that and go further. So here we go. We can say start at 0 and go until 1 million. In this case, we do three numbers between 1 and a million, or 0 and a million. And so we'll say it needs to have a length of 3. Alternatively, we could pass in a tuple here of 3 and 3. And that would end up giving us a matrix, which we can see right here, of values between 0 and 1 million. And then we can also do it with integers, and that will give us integers rather than float values. And those will be whole numbers, which is pretty cool. Okay, so that's just some background stuff. This is one of the tools we're going to use for this lesson because we do end up generating a lot of random data to mess around with throughout the rest of this. So there's that. We're going to look into Pandas. Pandas is a flexible data analysis library built on top of NumPy, so it involves and includes a lot of NumPy. That is excellent for working with tabular data. So it's going to be in tables. Again, SQL works with tabular data. Excel works with tabular data. Pandas also works with tabular data. It is currently the de facto standard for Python-based data analysis. So this is the tool for when people say, oh, you can use Python for data. This is what they're talking about. And fluency in Pandas will do wonders for your productivity and, frankly, for your resume. It's one of the fastest ways of getting from zero to answer in existence. So no clue about your data, and then going from there to knowing things about your data. It is one of the fastest ways to learn that. Other cool things about Pandas, under the hood, it operates a little bit different than regular Python. So it actually ends up being faster than regular Python. So yeah, it says right here, Pandas is a Python module written in C, programming language called C. You may have heard of C# or C++. C is kind of their grandpa. The Pandas module is a high-performance, highly efficient, and high-level data analysis library. It allows us to work with large sets of data called data frames. Data frames are really cool. Data frames are also, we're going to see this in R as well, but they're kind of like tables. They're very similar to tables like our Excel spreadsheets. A series is a one-dimensioned labeled array, right? So when we're using Pandas, when we're going to see things that look like lists, but that can also be like a column, right? And all the values in the column would be a series, or all the values in a row would be a series. And they can hold any type of integer, any type of data, whether it's an integer, string, float, objects, other data tables even. It can get pretty big. And a data frame, I don't recommend that, but a data frame is much like a spreadsheet, as I've said. It's got column headers, indexes, etc. So how to import it? First, we're going to do pip install pandas. My computer will say, you already did that. Yours might not, but if it doesn't, then congratulations, you've installed it. That is great. And then we can import pandas as PD. And that is how we would import it. And we shouldn't have anything thrown down here. If there is something thrown down there, that means you've got an error. And that is a problem. But we always use PD for pandas. That's just a standard for across data science for how we're going to do that. Tabular data structures. So we're going to start looking at some tables. So we already got some stuff going on here. We've got this list of names here, just plain old vanilla Python. And then we're going to say ages equals np random.randint. And it's going to be between ages of 18 and 35 for the length of names, right? So it's going to say generate ages for each one of these people, these characters, and give them an age between 18 and 35. And then we're going to put that in a dictionary called mypeople. And we want to see it at the end. And sure enough, we've got a names index with all of these names, and then an ages index, or series, I guess, with all of these. And so again, it says it's an array, and that's how we've got those. Delightful. So from dict is the first method that we're going to be looking at, and we're going to change this into a data frame. And this can be really hard to parse. It's really hard to like attach those pieces of data together. And so what we're going to do is we're going to use the from dict function. Is this filled out already? No. Okay, cool. I just wanted to make sure this wasn't already done. Cool. So yeah, so we're going to use from dict, and we're going to pass in my people from here. So make sure that you've run this. We're going to pass in my people into a Python, a pandas data frame, and use the dot from dict method. Save it to data, and then we'll run this. And sure enough, we get this. Now this is a whole lot cleaner. It's easier to read. It's easier to kind of imagine what's going on there. And we also get, just notice here that we get this column all of its own. It's not labeled by anything, but this is very similar to our primary keys in SQL. And so these are all going to be kind of unique IDs for each of these. So we could have multiple people named, oh look, there's Brandon. We could have multiple Brandons in there. And then all different indexes or different primary keys for those as IDs that keep them separate. So that's valuable. All right. How to read a CSV in pandas, because that's another important thing that we do here. And how do we analyze stuff using this? So we're going to pull it in and save it first. We say marathon equals pd.read CSV. We're going to pass in files. That needs to be a string. Files / this is very similar to how we did it with NumPy. Boston Marathon. Again, you might be asking, where are you getting this from? I have a folder called files here, and there I've got Boston Marathon 2017 edited right there. Boston Marathon 2017 _ edited .csv, because that's the data type. And then I want to separate it by commas. Right, and I should be able to spit out marathon. And remember, last document when we were messing with NumPy, it was still a little bit tricky to look at. It wasn't very pretty easy to analyze. And I opened it up in Excel so we could have a good look at it. When I run this here, we can see that this is actually, again, very legible. It's the same data. I mean, and then another thing is that it will tell us when we're using these data frames, it will tell us how big it is. So it's 26 columns. Right, so we got all of these different columns here with stuff like age, division, gender, and then how many rows they have. So we got about 26,000, 26,500 values in here. And you also notice that it automatically only pulls back some of those. It does not pull back all of them, which is also pretty nice because we don't want that many. All right. So in class exercise 1, go ahead and pause the video. It should be very similar to this right here. I do recommend that you use boss 17 and boss 18 to pull back specifically the Red Sox 2017 hitting and the Red Sox 28 hitting. Use those as your variables, because we will use these later in this document. And if you're like, where did you get that variable name from? You might be confused. So go ahead and do that. And pause the video, and then I'll show you the answer in a moment. Cool. So we say this is pd.read CSV. I'm going to pass in file / Red Sox 2017 hitting.txt. Sep equals comma. Pretty straightforward. We're doing the same thing here. pd.read CSV file / Red Sox, and this time we're going to do 2018 hitting.txt. Separated again by the comma. And for proof of concept, let's see what's in here. And there we get that. And you remember yesterday we looked at the same stuff, and it was, again, fairly difficult to read. This is much cleaner, much more organized. And even just from an aesthetic perspective, this is just a lot easier to work with. We also got these dots in the middle, so we can't quite see everything. We're going to learn about that in the future, how to kind of arrange that. But that's kind of the idea here. So we've pulled that in, and now that works. So accessing data. what if I want to pull back just part of this and look at it? Well, you can. That is, in fact, allowed. So first we're going to say this is just like you would do with the dictionary, right? Where you can say just pull this column back. It's very similar to dictionary syntax. The result is a pandas series object. So first I can pull this back, and sure enough, we get back just the ages, and this is from our my people data piece that we had earlier. And so we get just those ages back, because again, I could also just print data, and there we go. We get all of those, and that's fine. But let's see what happens if I print. Oh, we're gonna put this in the right space. Print type data ages. Put that in there, and we see on this line here, it's the class pandas.core.series.series. And so we see that in this case, that is a series data type. We could also do this with just data and see where that's at. And sure enough, we get a data frame there. So again, they've kind of created their own quasi-programming language going on here with its own kind of data types. And so just keep that in mind as well. Yeah, especially if you want to keep growing and learning more of this stuff, looking more into that information. Oh, there we go. Okay, I literally just did this. And this should be under here. There we go. Cool. Data series index, again, they do zero index here. R will be a little bit different because R does not zero index. When we get to that stuff, it'll be a little bit different. But we're going to have print data ages, and we can go to 3. And again, it's nice because the columns here actually tell us what the actual indices are. And so we should get back the value 20 here. Lo and behold, we do. So that's nice. Key first, row index second. Print data, and we're going to pass in ages, and then we're hand over 3. And so again, this is just another way of indexing to the same place. Get back 20 again. Cool. And this just changes things to a float. I'm not entirely sure why that's there, but you can change these data types for the output. Great. Cool. So df.lock, which is short for location. So along the horizontal dimension, rows of pandas data frames are row objects, right? And that's just a fancy way of saying that if you're looking at stuff that goes from side to side, right? Like this highlighted piece is a row. This whole piece of data from here all the way over, that is just a row. Pretty straightforward. You'll notice there's a third column present in the data frame. This is the index. And so this... Oh yeah, we're talking about this right here, this column right there. We talked about that already earlier. It's automatically generated as a row number, but can be reassigned to a column of your choice using the data frame.setIndex call name method. We can use it to access particular pandas rows, which are also series objects. So let's have a look here at what that would actually look like, and write some code. So first, let's just print out our data again. Print data and just see what that looks like, right? So we've got this here, and that is just fine. Cool. But we want to grab the first row of data by the index of the row. So we're going to say my row equals data.lock, and then we're going to pass in 2 here. So we could do, I guess, the 0th row. And we can just spit back out print. We use an f string here. I'm going to say location of the 0th row in the data. And then we're going to pass in my row. And actually, I want to add another backspace or \n there, so that then we don't have to worry about quite as much drama. And so the 0th row in the data is Alice, and the age is 29. So this is basically just pulling back this, and it's at the 0th spot. We can do this again with the value 3. I'm going to put that over here and do this again. Location of the 3th third row in the data. And now we are getting back Beth. The age is the value is 20, and it's an object overall. Cool. What about if we want to get multiple values back? So this is actually going to be a little bit tricky at first, but I think once you realize what's happening and I explain it to you, it'll make a lot more sense. So multiple peeps equals data.lock, and I'm going to make this really big so you can kind of see exactly what's going on here. Inside of here, I'm going to pass another object, right? So normally I could pass like the value 5, that kind of thing. We're actually going to create another array inside, and we're going to do 0, 1, 2. That's just fine. And then, so this is saying I want to find the 0, 1, and 2th values, and then we have to say which actual column we want to pull from, right? And so now I can print out f location of multiple people, and then pass in multiple peeps, and see what happens here. So now, sure enough, we get 0, Alice, 1, Bob, and 2, James. But in this case, we're not getting those ages back, right? And so that's what we're doing there. And let's see something else interesting just for funsies. Let's do print type multiple peeps. And sure enough, we get a series there, right? So again, that's kind of like their version of an array. And that's because we're just pulling back just the column in that case. But it did add the 0, 1, and 2. So there's the 0th, 1th, and 2th values of names. But it did attach those to it so that we can still see the differences of them rather than just sending back a pure Python list, which might seem annoying. Maybe you like that, maybe you don't. But just keep that in mind as you're doing this, that is the type of data that we're getting back. And this is a good thing to just be checking as you're doing stuff, just to make sure that what you're working with is what you think, because again, things can look a lot like other things when we're doing this. Using df.location and producing a data frame at the end. This is pretty cool. So multiple peeps data frame equals data.location. And we're going to pass in, again, 0, 1, and 2. You don't have to have these spaces in here. I just think it's easier to think about it because it gets really confusing with lots of those. And then we're going to pass in another array over here for names and ages. We're going to say print /n multiple peeps data frame. See what that looks like. Let's go down here and we get that. It's very nice. It's actually a lot easier to look at. Oh, I wanted to do right here. There we go. It's a little bit easier to look at too. But sure enough, we get actually another data frame in this case out of that. And so I could also print multiple peeps data frame, and sure enough, we will get a data frame back, which is neat. And so then you'll be able to do other things on that. Resetting it. This is that set index where you can change some of that information. So we're going to do reset index equals data.location, and we're going to pass in 0, 1, 2, and 3. So just the first 4 values of our thing here. We do set index. We're going to pass in names, and then we can print. Well, so if we print this here, it won't actually be useful yet. So you see that nothing comes out actually, which is kind of weird. Usually print will at least send something, but we need to actually use the location function here, Alice. And now we will get back Alice itself, or herself, and her age, and her name, and then the data type and stuff, which is cool. Yeah. and we're not going to do those. Those are other things people have worked on that just ended up in the notes, so that's fine. Cool. Keys are cool. So again, this is in here for some reason, but data keys, and this will access all of the keys or columns of the data frame. And so it's cool because you can get those keys back. Here, let's actually comment these out real quick. What I want to do is print data.keys so you can see it. And sure enough, we have the key of name and ages, and that's fine. And then once we use these, we get an index back, and I might look here. Is this what I wanted? I don't think that's what I wanted. I think I wanted this one. That wasn't what I wanted. I did want. There we go. There's our keys. So dot keys. What does it do? It's noteworthy as well for our keys that if we are operating out of a data frame, so essentially, and I highly recommend if you're curious about these things, if you want to learn more about them, using Geeks for Geeks. They have really great articles on this stuff. Pandas dataframe.keys function returns the info axis for the pandas object, right? So if it's if the object is a series, then it will end up returning the indexes. If it's a data frame, then it returns the columns. And then we aren't messing with panels, but it will pull back the major axis. That's not for scope of this lesson, but you can see that it sent back an index because our keys is a series, and so it's going to bring back that index. Yeah. Cool beans. So, and then we made it into a list, right? You can take a series and make that into a list, or you can take an index, group of indices, make them into a list. Slicing a data frame, this is very easy to do. We can just say data, I want the 2 through 5, non-inclusive, so we get values 2, 3, and 4, James, Beth, and John. We get those back. We will stop here. Just to cut the video, just to keep it in bite-sized chunks, and I will see you in the next video.